Welcome to part 2 of the SAS system for Windows. In this video, we will cover data entry in the editor window. Let's return to the editor window. I have provided a small data set for the first week's analysis in the course. It is a text file by the name spaw1.sas. This is short for Statistics in Plant Agriculture Week 1. It contains 100 seed weights of 10 samples of 2 plant species, corn and sunflower. Place this file in a directory that is accessible by your computer. It could be on the hard disk, on a memory stick, or on a shared network drive. I have also provided the example data as part of the description text for this video. We'll begin by opening this file. When the input window is active, go to the ribbon, select File, Open Program, navigate to the directory that the file is in, and open the file. The file contents will open and be placed after the cursor in the window. The file contains 20 rows of data arranged in 3 columns. Each row is an observation. The first column is the observation number. The second column is the plant species, which is either corn or sunflower in this data set. And the third column is the weight in grams of 100 seeds of the sample. SAS can use data in any format, but the easiest for most users to manipulate is this row-column format. This is exactly the same format as you would see in a spreadsheet. Instead of having the data in a SAS file, I could have pasted it into this window from the original source using the Windows paste command. For example, I will remove this information that we just opened up and go to my Excel spreadsheet. I'll block the data area, copy it to the clipboard, and return to the SAS editor window. I can paste the information in. And it looks like the original data set I had just opened. There are many other ways to access data in the editor window, but the copy-paste is the easiest for most users and avoids compatibility issues among software programs. Now we have some data in this window, we need to give SAS some instructions as to what to do with this information. These instructions are collectively called commands. You usually need to do a combination of the following: title your output, enter your data, manipulate the data, such as computing new variables, parsing, or combining various data sets, visualizing the data, analyzing the data, and saving or capturing the analysis results. I'll first add a couple of blank lines above the data area. The first command line I will insert is the title command. In this case, I will use as my title, "This is my first SAS analysis." One key thing to remember with SAS program statements is that the semicolon is used to indicate the end of a command line. Forgetting to insert the semicolon is the most frequent error students have with the editor window. The second most frequent error is not including both the opening and closing quotes. If the closing quote is missing, SAS will continue searching for the next quote and assume that all information between the two is a title. Sometimes the command lines can get quite lengthy. They don't have to appear all in one line. SAS will search for the next semicolon and automatically combine the sequence of characters into one command line. For example, if this title line is broken up into 3 lines or 4, SAS will take the entire sequence and make it into one single command line. You will note that different colors are displayed in this window. Commands SAS recognizes will be indicated in blue. I will insert an error into this title request. Note that it is now displayed as red, indicating an unrecognized command. I will leave this error in to illustrate what the SAS program might do in such cases. The title command requests that all pages of output have this title placed on the first line of every page. As you proceed through analysis steps, you can change the title by inserting a new title line. SAS will use that new title from that point forward. It is also possible to include subtitles. The title to command inserts a title on the second line of every page. If you need to, you can add additional subtitles using the title 3, title 4, and so forth commands. Although you could create these lines in a word processing program and paste them into this window, be aware of a problem with the single quotes. Word processors, and I'll open one up here, automatically replace this symbol with two other symbols, an opening and closing quote. SAS does not recognize the latter, so if you paste it from a word processor, you will need to replace the quotes because they are not the same as the single quote that SAS requires for a title line. The next statement I'll introduce is the data statement. This command lets you create data sets or manipulate existing data sets. These data sets that are created are electronic versions that SAS uses during analysis. You don't have to, but it is advised to name the electronic data sets that are created. This makes it easier to combine or subdivide data or point to specific data sets for certain analyses. The convention I use is to name the data sets in the order that they are created, using the words first, second, third, fourth, and so forth. Since this is the first data set in this particular analysis, I will name it first. Again, don't forget to include the semicolon. The next command line is the input line. This instructs SAS how to interpret the data area. In this example, there are 3 columns, so we need to define 3 variables, one for each column. The variable names can be alphanumeric, but need to begin with a letter, and each name contain no spaces. I could use the names such as V1, V2, V3, or C1, C2, C3, but it's easier to refer to short names that make sense in the analysis output. The first column is a sample or replicate, so I will call it rep. The second column is a species, so I'll call that variable species. And the third column is 100 seed weight, so I will use an abbreviation for 100 weight, WT100. And end the sequence with a semicolon. Now we have 3 variable names that correspond to 3 columns in the data area. Unless you specify otherwise, SAS assumes variables are numeric and will attempt to interpret the data region accordingly. With this method of data input, strings of characters that have a space in either end will be converted to a variable value. For the first row, it would convert the digit 1 into the number 1, and that would be the value for rep. It would find the next character string, in this case CORN. Since this can't be converted to a number, it would skip that and go to the next string, and convert the characters 17, period 66, and convert that to a value. And that would be a value applied to the next variable in the list, in this case species. And it would continue into the next row and place the value 2 in for the weight 100 variable. Obviously, that's not how we want this data to be interpreted. So in order to have this area interpreted correctly, we need to indicate to SAS that the variable column species involves alphanumeric values. To do this, we add a $sign after alphanumeric variables in the input line. The $sign can be right after the name species or separated by a space. Either way, it's an indicator to SAS that the variable species has alphanumeric values. Now it will interpret the data area correctly. Once we have defined an alphanumeric variable, we don't need to include the $sign when we refer to the variable. Using this input method, if you happen to have values that include spaces, such as Guelph corn, you will have to remove the blank to create a single string of characters. In your spreadsheet, you can do a global replace of the blanks in the spreadsheet column with an underscore symbol to combine the two parts, Guelph and corn, together as Guelph underscore corn. By default, SAS will abbreviate alphanumeric values to the first 8 characters. In this example dataset, this is not a problem since the species designations only involve 4 characters. But you will have situations where you need to alter this default. For example, if you had Guelph underscore corn, that would be shortened to Guelph underscore C. If your variable values are greater than 8 letters, you can override the default by including a length statement placed ahead of the input line. Here I've added a length statement defining species as an alphanumeric variable and indicating it can have values up to 20 characters in length. You can enter the value that is appropriate for your particular study. I'll remove this statement since it is not necessary in this particular example. For those of you using the University Edition, note that you will require an in-file statement prior to the input line to indicate to the program that the columns are separated by tab stops and not by physical spaces. This in-file statement specifies that tab stops, rather than spaces, separate columns. This command is not necessary if you are using the PC Windows Edition. We now need to insert another command line after the input line to indicate to SAS that the next series of lines are data and not command lines. When the program was first developed, the command was the word cards. This goes back to the era in which data was read into computers through key punch cards. I will insert the command cards with a semicolon. Note that the data area becomes highlighted in yellow. It is important now to go to the end of the data area and add a semicolon on a new line. This signifies to SAS that it is at the end of the dataset, and from this point on the characters will be interpreted as command lines. Make sure the semicolon is on a separate line. If it happens to be placed on the last line of data, as I illustrate here, note that the last line of data is no longer highlighted in yellow. SAS will not use this line of data in the analysis. So make sure the semicolon is placed on a separate line. An equivalent command to the card statement is the command datalines. It has exactly the same function as the card statement. I prefer to use the card statement because it takes less time to type. This concludes part 2 of the tutorial. In part 3, we will cover additional data manipulation in the editor window.